Hello everyone, we are starting a new section, and that's on curve sketching for polynomial functions, and it's a very important lecture. I hope you're going to pay heed attention. And in this section we want to draw sketches, but not very accurate graphs. I repeat, sketches of polynomial functions whose equations are given in factored form. If they're not in factored form, then we have to use our factoring skills to factor them, but we are discussing only the ones that are in factored form. So right now I have this giant polynomial function. There is 4 binomials in product form, so I would say the degree of this polynomial function must be 4. So n is equal to 4, I say. It's a 4th degree polynomial function, quartic function, but it's in factored form, all right? And we want to know how we draw a sketch of this function. Before that, I have to define something, because when you look at different equations of polynomial functions, they are all in factored form. Sometimes some of these factors, they do have an exponent. Okay, those exponents are called the order. The definition of order is right here. The exponent to which every factor in an algebraic expression is raised. If you have x minus 3 to the exponent of 5, then this factor has an order of 5, okay? So right now here I have 4 binomials, and all of them have the same exponent of 1. So the order is 1. But in the next example, the exponent of x plus 4 is 2. So that, we say the order of x plus 4 is 2. But the order of x minus 7 is 1. Here, the order of x plus 2 is 4. Here, the order of x minus 3 is 3. So you see that different exponents, different orders for different factors. And this is going to affect our curve sketching, of course. If you have an order of 1, such as x minus 3, for example, at the 0 of the function, wherever it is, what is happening is that there's a simple crossing happening, okay? Either you go from bottom to top, or you go from top to bottom, depending on the end behavior of the graph. But what is happening is a simple crossing with order 1 for the factor, okay? If you have another 0 somewhere else, okay, and the order of your algebraic expression is 2, like here, for example, or like here, okay, the order is 2, in that case, bouncing is happening, just like a parabola. So the graph could bounce up like this, okay, or it may even bounce down. But what is not happening is crossing. Crossing is not happening. So depending on the end behavior, it's going to be either bouncing up or bouncing down, okay? And if the degree is 3, or even 5, 7, if the degree is odd, okay, odd number, always crossing is going to happen, but the type of crossing will be different. For an exponent of 3, for order 3, we are going to have a crossing, but not like a straight line, okay? It's not going to be like a straight line. It will be like an inflection point, we call it. So it's going to look like something like this, okay? So we're not saying bouncing is happening, crossing is happening, but it is not like a straight, simple crossing of the x-axis. It's like it has a little bit of curvature, so we call these kind of points inflection points, okay? Because the graph changes its concavity. And if the exponent is 4 or 6 or 8 or any even number, again, bouncing is going to happen. But what's the difference between when we have an exponent of 2 or 4 or 2 or 10, both are even numbers? Well, the so-called vertex, or the lowest point or the highest point, will become flatter. So it's going to look like something like this, It's going to be a bit flat, but still it will be bouncing at that x-intercept, okay? And if the exponent is a high odd number, we're going to have an inflection point, but it's going to be flatter inflection point. Something like this, perhaps, Same nature, but a bit like flat at the x-intercept point. So this is the general, idea. Now let's start doing these questions very quickly. The first one, we have zeros at 6, -2, -5, and 3. So this is This is 6 here. Okay, I just sketched them, and then we have 3, and then we have -2 right here, and we have -5. Okay, -5. We said that the degree is 4, it's an even number. So from the end behavior analysis, considering that the leading coefficient here, leading coefficient is actually positive. So leading coefficient is greater than 0 because it is equal to +2. So we know that the graph should extend from quadrant 2 to towards quadrant 1. So the end behavior should be something like this and something like that. Okay. So what is happening here at -5? Well, simple crossing is happening. So it's going to be crossing just like that. And then at -2, again, because order is 1, simple crossing is happening. At 3 and 6, the same thing is happening, simple crossing. So now we fill in the blanks. So we know what's going to happen here. So the graph is rising on the left. It's going to go down like this, cross, and then we must have a turning point because it can't go down because it has another 0 to pass from. So it's going to make a U-turn, come back, and then same thing happens here, and then same thing happens here, and then it goes all the way towards positive infinity. And this is going to be the sketch of this polynomial function, okay? It's just a sketch of it with the zeros shown, correct end behavior, and that's all we want. If you plot this point a little bit lower, a little bit higher, 1 millimeter lower, 1 millimeter higher, it is not an issue because we are interested in a sketch. So when you draw this graph, you may draw this a little bit lower, okay? Or when you're drawing this point, it could be like lower instead of higher. This could be like lower instead of higher. It doesn't matter. What we care is the general sketch. We want to see the zeros are correct. We want to see turning points are correct. We want to see the end behavior is correct. These are the things we are interested. So we're not interested in a very, very accurate graph. So we're not picky about this point going a little bit lower or a little bit higher. Okay. Mind you, with a good thing to calculate the y-intercept and actually labeling it. All right. So here, if you use a calculator, perhaps we can even do that. So -8, I'm plugging 0 for x, -8 times 2 times -6, okay, times -6, and then times 2, it gives me the answer of 192. So that tells me that the y-intercept must be 192 actually. I can just label it because, as I said, you're not drawing a very accurate graph. If you just label, that's good enough. Label the x-intercepts, label the y-intercept, good enough. So next one, the degree is, of course, 3, and the leading coefficient, which is -3, that's less than 0. So 3, 4, 5, and 1, we have to add the exponents. That is 8, I believe. So degree is 8, leading coefficient is positive. 7, 8, 9, 9, and 5 is 14. So this is a 14th degree polynomial function. The leading coefficient is negative. This one is 2, 3, 4, 5, 6. So this is a 6th degree polynomial function, and leading coefficient is -1, less than 0. I just did all of them in one shot. And now, to draw the graph, we are going to say the following. The zeros are at 7, so this is 7 and -4. This is a sketch. And in terms of end behavior, because it's an odd degree cubic function, and the leading coefficient is negative, so we should extend from quadrant number 2 towards quadrant number 4. So 2, 2, 4, just like this. So it's going to cross here. Now at -4, it can't cross. Can't cross because the order is 2. So here what is happening is a bouncing happening. So it has to bounce up, obviously. And then it can't go all the way. So it has to make a U-turn, come back at some point because it has another 0 to pass from. So this one is just an order 1. X minus 7 is a factor with order of 1. We defined what order was. So a simple crossing is happening here. And this will be the basically general sketch of the second exercise, second polynomial. Okay, we do C. First I plot the x-intercepts. So we have a 5 here, we have a 3, of course, and then we have a -2, and this is 8th degree. leading coefficient is positive. So that's very clear. It is rising on the left, rising on the right, according to the end behavior discussions we've had in the past lectures. And at -2, the order is 4. So it's going to be a flat bouncing happening here, flat bouncing. At 3, we have an inflection point. At 3, we have an inflection point. So it's going to look like this, okay? And at 5, because x minus 5 has an order of 1, it's going to be simple crossing happening there, okay? So the graph will look like this if I fill in the blanks, okay? It's going to go down and go up, and this is how the graph of function C will look like, okay? Next one is n equals 14. It's an even number. So the leading coefficient is negative. So that tells me that we should start from quadrant number 3 and end up with quadrant number 4. So it is basically falling on both sides, falling on the left, falling on the right. The results are 1 and -1 and -7. So this is -7. This is -1, and that is +1. Okay. And what is happening at -1? At -1, well, let's start with -7. At -7, we have an inflection point. It's a flat inflection point. So it's going to look like something like this. Okay. And at -1, at -1, we have an exponent of 7, which means that the order of the factor x plus 1 is 7. And that is very flat because the exponent is a high odd number. So we're going to have an inflection point at -1, but that inflection point is very flat. So something like this. Now, it's hard to show because these are not drawn to scale, but something like this. Okay. And then at 1, we have just bouncing happening. So it has to be bounced down, just like a parabola. It's not that much flat. And this is going to be the end behavior on like in quadrant 3 and 4. So that's how the graph of this 14-degree polynomial function will look like. We have a 0 at -1, we have a 0 at 1, another 0 at -7, inflection point, flat inflection point happening at -7, 0, and then another inflection point happening at -1, and a bouncing happening at x equals 1, the other x-intercept. This last one has a 0 at the origin. So this is the origin. Then we have 3 on the right side and -4 on the left-hand side. So these are the 3 zeros. Degree is 6 and leading coefficient is negative. So it should be falling on the left, falling on the right. So the shape should look like something like this on the left and right side. What is happening at -4 is an inflection. So here we have an inflection point. Okay, that's what's happening. Then at 0, we have x squared. So that is like x minus 0 all squared. And that means we have a bouncing like a parabola. Okay, so that's what is happening at 0, which is the third 0 of the function. And at 3, the exponent is 1. So the order of x minus 3 is 1. Therefore, a simple crossing is happening. And it's going to look like this. So this was A, B, C. This was D. And this was E, of course. And these are the general sketches, general shapes of these polynomial functions. And I hope you understood how we quickly sketch these. And as I said, we're not picky about these turning points to be a bit higher or a bit lower. We are interested in general sketch of the polynomial function. It requires lots of practice. I assume that you are watching this video lecture multiple times. Nobody will understand things in like by watching once. I have some restrictions in recording these videos because time constraint is the issue. Normally in class I would spend 75 minutes discussing this, but right now I have maximum 50 minutes to wrap this whole thing up. So, but then the advantage is that you can watch these videos like 20 times if you want. You can pause them, you can rewind them, and I suggest you do that. You must do that one by one. Try to do it by yourself. See how it's done. Try it by yourself, and review these lecture videos as many times as you can, as many times as is necessary. Thank you, and keep practicing.